0 point. All we have to do is exert a strong enough external force, focused and targeted with the right resonant frequencies to hit the harmonics to unwind the way the information field's been organized in that locale. We just unwind it by exerting an external force. Victor Schauberger proved that beyond any question, and it's been done lots of times since then. I mean, why they're using rocket fuel and perchlorates to launch Greyhound buses into space, I don't know. Doesn't make any sense. But the fact of the matter is they know better. They know how to do it different. And they have done for a long time. But this explains why. This takes the mystery out of it. So, look. Let's make a long story very short. Pentaquarks. 5 quark combinations that form really interesting materials, not supposed to be theoretically possible, but verified. Now, this is really an important piece. This is a photograph of the Bose-Einstein Condensate at 1/10 of a degree. This is literally a tunneling, scanning electron microscope photograph of it. Now, I want you to notice what happens here. Look at this divider at the equator. What is that thing doing? It's going like this. It has opposite spin. Look at what it's creating. It's creating vortexes. Look at the angles of those vortexes. They're optimal.
What's the scale of that picture?
That scale, it is, let's see.
Approximately. Just.
It is finer than 1 atomic diameter.
Thank you.
At 2/10, that piece of material in a hard vacuum expands to create 23 other kinds of matter. Just in 1/10 of a degree Kelvin, it changes its properties and explodes into 23 other kinds of material. That they didn't expect. And then they drop the temperature, and bingo Bobby, she comes right back down and recondenses. So what you have now is a picture of the epitome of Y-bias and angularity. What the Y-bias notion says is that the angle of intersection of information bundles, matter, energy, field effects, whatever they are, the angle of intersection is dispositive. And there are optimal angles and there are minimal angles. And they determine what is able to rise above a noise threshold at a quantum level and what is not. What will persist and survive and be robust, and what will collide and disaggregate on its own and go back to a lower energy state. It's the angularity of the intersection that's dispositive. And I want you to look at that and remember that picture, because those angles and those archetypal shapes are the quintessential proof that all the dynamics described by those laws of self-organizing criticality are absolutely embodied in that photograph. And that's why that's what's on the first page of our website. All right. What we have here are pictures of Ken Shoulders high-density charge clusters. That's what it looks like when a neutron disaggregates in a sonication chamber. These are photographs of things that take on archetypal shapes, high-density charge clusters. 1 micron diameter here. It's a torus, an archetypal shape, a torus, that if it expands to 3 dimensions becomes a vortex. And they organize themselves into rings that create a 10 micrometer ring of rings. These are scanning electron microscope photographs of accretion disks in atomic structures that do exactly the same thing in the same way for the same reasons. The vortex is archetypal. It is archetypal at all scales. There's the soliton. There's the standing wave. That one happens to be 600 feet in diameter. It's still a smoke ring, big cigar. You know what I'm saying?
I guess.
Our guys put together the math and sent them to Tom Banchoff at the University of Illinois, and he and his guys ran the algorithms on it. The data that comes out of our model, by definition, creates a torus. And that's what a high-density charge cluster is. Electrons burst in Avogadro's number off the end of a probe at a high voltage, organize themselves. Instead of just dissipating and going away from each other, they organize themselves into a torus, which is a stable configuration. It is a standing wave. It's a soliton. And we find them ubiquitously throughout nature. There's the vortex that results from that soliton when it goes into a further expression. There's the same archetypal shape. It's exactly the same shape, exactly the same dynamic, exactly the same rules, just at a different scale. This one that was before it is Hurricane Katrina. Well, didn't we see that before? Haven't we seen that shape before?
Oh, the galaxies.
Have you ever heard of a phallico-soliton? You want to have some fun? Take a frisbee into a swimming pool sometime. Let the water get nice and smooth. Spin the frisbee around 3 or 4 times, then pick it up out of the water and stand still. 3 times out of 5, if you do it right, another vortex will appear somewhere else on the surface. And if you have an eyedropper with a drop of ink in it, if you drop it in one, it'll go right down under the water and come up in the other one. They self-organize. Complementarity is part of the function. It's all about these very basic fundamental rules. And it works all the time, and it works everywhere. Look, the Earth and the Moon are a standing wave by definition. And so are the other planets in the solar system. And guess what? If you look at the distribution of mass in our solar system as a function of Fibonacci relationships in terms of how far the relative masses should be spread from each other, we are 0.00043% shy of a perfect Fibonacci distribution all the way out to Pluto. And it's only because of the irregularity of Pluto's orbit that we have a variation. And Pluto's not a planet, so.
What's it doing?
But you know, that's got to say something to you. It's got to say something to you. And so here we are, and you look at this wonderful thing called Hoag's object. This is galaxies. This is star, but this is a ring of galaxies around this galaxy. These are galaxies each. Galaxies each. Tell me that's not a standing wave. It is. The Sombrero Galaxy. Same function, looking at it end on. It's ubiquitous in the cosmos. And at the center of it, here's how the law of thermodynamics really works. At the physical vacuum, there is always fundamental balance. The physical vacuum is always in balance, everywhere. At every locale, there's always imbalance. Because everything's in motion. It's vectored in one direction or another. And it is that imbalance, as a function of the organization, that creates the fractal record that shows us where we've been. That's the way it works. The way the universe stays in balance is that at the same time that it is organizing these tornadoes, it's unorganizing them in a way called black holes. What black holes do is just unwind everything the tornadoes created. Same dynamic, exactly the same. And we know they're for real, and we know what they look like because we got pictures of them, thanks to Hubble. Look at that. I mean, you've got galaxies colliding, you've got black holes eating them. There's an extraordinary photograph of a black hole eating a star, disaggregating it. And what happens is that it takes all that information, all the stuff that came up from the physical vacuum, up to all those scales, you put it inside the maw of that black hole, and its function is to create such pressure, to create such velocities, to exert such extraordinary force that it literally disaggregates it and redeposits the undifferentiated potential back into the physical vacuum.
Continuous creation.
There's no such thing as a Big Bang.
David, why don't you discuss a little bit on the nuclear stuff?
I will. Okay, so we've got a whole bunch of other stuff here. We've got three technologies. I'm just going to tell you what they are. I'm not going to spend any time explaining because I know everybody's going right straight to sleep.